Hi, and welcome to my second video about Hibernate performance tuning. In the last video, I showed you how you can find performance problems before they occur in production. And today I want to show you how you can fix one of the most common problems, the n+1 select issue. When you started with Hibernate, you probably learned that you should use fetch type lazy for most of your relationships, so that Hibernate doesn't fetch entities of a relationship you don't need. It's obviously a good approach to read only the data you need for your use case. But if you use a lazy relationship, Hibernate has to perform an additional query to fetch it from the database. This often results in a huge number of select statements and a slow response time. You can avoid that when you tell Hibernate to initialize all required relationships with the initial query. I prefer to do this with a named entity graph. Let's have a look into one of the lectures of my online training about Hibernate performance tuning, in which I explain that in more detail. Named entity graphs provide an annotation-based approach to define a graph of related entities which shall be fetched from the database. And as I said, the definition of the graph is independent of the query, so you can use this graph with different queries, or perform a query with or without the named entity graph. As you can see here, the definition of a named entity graph is quite simple. You only need to provide the name of the graph and a list of attribute nodes which shall be fetched with the query. The graph in this code snippet can be used together with a query that selects author entities to tell Hibernate to also initialize the books property, which keeps a list of book entities. Okay, defining that graph was easy. But initializing only the relationships of the selected entity is often not enough for a real-world application. You often also need to define the fetch behavior for the related entities. You can do this by adding subgraph definitions to your named entity graph. As you can see in the code snippet, the definition of a named subgraph is pretty similar to the definition of a named entity graph. You need to provide a name and a list of attribute nodes. You can then reference the subgraph in a named attribute node definition. So if you use this named entity graph with a query that selects author entities, Hibernate will get all books of that author to initialize the books property, and also get all the reviews for each of the books to initialize the reviews property. Okay, before we can try that out in the IDE, I have to show you how to use a named entity graph. As you can see in the code snippet, there isn't much to do. You call the getEntityGraph method of the entity manager with the name of your graph, in this case with graph.authorBooks. By doing this, you get an instance of your graph that you can then provide as a hint to the query. You saw on the previous slide that I used javax.persistence.loadGraph to define the hint. This is one of the two ways defined by the JPA specification to use an entity graph. You can either use it as a fetch or as a load graph. And the persistence provider will use eager fetching for all properties that are part of the graph definition. But they differ in the fetching behavior for properties which are not part of the graph definition. The fetch graph uses lazy fetching for these properties, and the load graph uses their defined fetch type. But for now, you can ignore the distinction between these two kinds of graphs, because Hibernate does it as well. As long as the bug 8776 doesn't get fixed, Hibernate handles all entity graphs as load graphs. The behavior is also allowed by the JPA specification because it allows all implementations to fetch more than the specified information from the database. And that is what Hibernate is doing by treating fetch graphs as load graphs. Okay, but let's get into the IDE now and have a more detailed look at what Hibernate does when you use an entity graph. Now let's have a look at the more complex graph definition. I annotated it also at the author entity, and it is called graph.authorBooksReviews. I showed you the same graph definition on the slides, and it uses a named subgraph to define the fetch behavior for the book entities to also initialize the reviews relationship. I used this graph in the test named fetch graph author books reviews method. There are two differences compared to the previous test method. I of course changed the name of the used named entity graph, and I use a different method to write the log message. This one also logs the number of reviews of each book. Everything is identical to the previous method, so let's just run it and have a look at the log output. You can see in the session metrics that Hibernate got all authors and their books with all their reviews within one query. As you've seen, you can use named entity graphs to define which association Hibernate shall fetch from the database and to avoid n+1 select issues. In the next video, I will give you an overview about the different caches you can use with Hibernate. Have a great day and see you in the next video.